the first thing to do is identify the shape of the graph. And all of us realize this is a parabola shape because of the x squared that's in the equation. Then they're all going to be parabolas for a while. Okay, the test we just took, we had absolute values, we had all those things. It's a U shape. Okay, now the equation also, guys, when I'm talking, I don't want y'all to be, please. The equation also tells me here that I'm going right 1 and up 4. So that's where the vertex moves, right 1, up 4. And then the negative tells me it's just being flipped upside down. Now, some of the things I was noticing is it's upside down. If you move the vertex first, then it's upside down from wherever that is. Or you could flip it first and then translate it. Either one works, but I think it might be easier for us to just move the vertex and then flip it upside down right there. Okay? So now the parent shape goes typically, I'll draw the parent real quick. The parent shape typically goes right 1, up 1, right 2, up 4, and left 2, up 4. So this is the parent. But now I'm going to draw the graph I've been asked to. So it's going to go right 1, down 1, left 1, down 1, right 2, down 4, left 2, down 4. And it's literally just the upside down parabola that's been shifted. Okay? Zakira definitely did. Okay? Yes.
So you don't move the other points right 1 up 4?
You just start with your vertex. The vertex, I can only answer one question at a time, folks. Okay, so I move the vertex, and then I look at the pattern from the parent, from that vertex. By the way, what is the vertex? Let's go ahead and write the coordinates of it. What are the coordinates? What'd you get, April? What'd you get for the vertex? 1, 4. Very good. Is it a maximum or a minimum? It's a maximum. And that's going to become important because we're going to need to know that on our calculator when we bring our calculators in next class. Next class. Shh. Maximum. Maximum. Highest point. Okay. We also need to write what the axis of symmetry is. And we talked about what that was just a second ago. The axis of symmetry in our case here is just the vertical line that passes through the vertex. Vertical lines are always x equals a number. What's it going to be here? X equals what? 1. It's always the x coordinate of our vertex. Good. All right, go ahead and erase your boards. We're going to try one more, and then we're going to move on to standard form. Okay? So one more.
All right, y'all, give me a hard one.
I'm going to give you a hard one. Pass your pen. I'm trying to find a hard one here. Lots of 2s. All right, here we go. This is the hardest one we're going to do today, at least with the graphing. Okay, I'll pause the recording while you guys look at these. Again, recognize it's a parabola, decide what transformations are happening without a calculator, and then we're going to graph it. It looks to me, for the most part, like most of us got it. So let's go through and make sure. I'm looking for not only the graph, but the axis of symmetry and the vertex, and whether or not it's a maximum or a minimum. So without a calculator, we need to go ahead. I'm just going to draw the parent first, just so we establish our pattern of what the parent is. So we know, according to the graph here, the transformations are right 4, up 4, reflected upside down, and it's been stretched by 3. Okay? So those are just my shorthand notations for being stretched upside down and moved. So I'm going to move my vertex first, right 4, up 4. And then I'm going to realize that it's been upside down and the pattern is being stretched by 3. So rather than go right 1 up 1 like the parent does, I'm going to go right 1 down 3. I'm going to do the same thing on the other side because parabolas are symmetric. And I can go right 2 down, because 4 times 3 is 12. Very good. So right 2 down 12. Well, all the way down here. We can just kind of go reflected across this side like this. And then we know that this is, well, that's where we got to be. So this is the graph. It is a lot skinnier than the parent. Did we expect that? We should have expected it because this 3 tells me it's been stretched. Now, what is the vertex? It is a maximum, I agree, and the coordinates are 4, 4. Now, what about the axis of symmetry? And I abbreviated AOS just so I don't have to write it all the way out. It's x equals what? 4. Because it is this vertical line that passes right through here. Very good. Okay? Now, what I'd like us to do is I'd like us to take this equation, and you can go ahead and do it, put your pens down for now. This is something you need to write in your notes. Okay? So erase your boards, close your pen on your marker. And I'd like us to take this equation that I just gave you. Actually, let's start with the easier one. Let's go backwards for a minute. Which one was easier? This one's a little bit, let's do this one. This one's a little bit easier. So negative x minus 1 squared plus 4. Okay, good. All right, so this is a special form of a graph called vertex form. Okay? So I'm going to go ahead and ask you guys to put the boards and the erasers and everything on the inside of your tables, and you get your notes out for me, okay? This form of the equation is called the vertex form. And eventually, we're going to be taking equations in different forms and putting them into vertex form by something called completing the square. But we're going to do that next week, or maybe even the week after. But vertex form is an easy way for us to see what the vertex is. Because we know from a transformational standpoint that this means right 1 up 4, don't you? We did that, right? Well, what does that mean? That means that the vertex can be found by just saying right 1 up 4. That's the vertex. Vertex form it's written that way so you can see what the vertex is right away. That's all. The vertex is 1, 4. And we have that. The vertex was 1, 4. If we go here, what's the vertex of this without looking here? Negative 1, 2. And we had that. If we look at any equation, like this one, the vertex was 4, 4. So we should be able to look at something in vertex form and quickly find what the vertex is. Okay? There's another form of the equation, and it's called standard form. And this is what we're going to finish off with the rest of class today. Standard form is what we're really going to be working with starting on Friday and next week. And honestly, it's probably what you spent most of your time doing in Algebra 1. So Travis, you should be writing this down. Shamar, you should be writing this down. Okay, good. Then you're going to be good at this. Okay? Standard form. Vertex form, and I'm going to write it in these kind of strange letters. Okay? But vertex form has something special. And I want to write it exactly the way the book does it. So I'm going to, here we go. All right. Vertex form looks like this. Okay, so you need to write what that is. Vertex form looks like this. Y equals A, parentheses, x minus h, close parentheses, squared plus k. HK is the vertex. Okay, so HK is what the vertex is. A is how far it's been stretched. A can be positive or negative, and that just means it's been flipped upside down if it's negative. But HK is the vertex. Now, standard form is what you're actually used to seeing, okay? And standard form, and I'm trying to make sure it's exactly like the book says it here. No. It's the same thing as y equals, that's right. Now, this is standard form. Okay, ax squared plus bx plus c. Now, the a that's in front of the vertex form and the a that's in the standard form are actually the same a. It tells us how far it's been stretched. Okay? What we're going to do is we're going to have to go between the two, between vertex form and standard form. Why is vertex form from a graphical point of view a good thing? Why do we want equations to look like they are in vertex form? What can we find easily and quickly? I can see the transformations. I know where the new vertex is. And I can graph it pretty easy, right? That's what we've just been doing. We can graph it really easily when it's in vertex form. When it's in standard form, it's not as easy to graph. Okay? So we're first going to go from vertex form to standard form. And then later in our unit, we will go backwards because we want to be able to graph it. Here are the steps to go from, right now we're going from vertex form to standard form. Okay? So step one. You ready? We have to multiply the binomial. What does that mean, Mrs. Knocker? I'm going to show you. Right here, and I'm going to highlight the steps so you can see what I'm talking about. Here is my binomial. Binomial. Why is it binomial? How many pieces does it have inside the parentheses? 2. X minus 1. It's a binomial. We're going to eventually get it to look like a trinomial. It's going to have 3 pieces. Okay? How do I multiply x minus 1 squared? So let's do that. X minus 1 squared, and this is a mistake that so many people make. It is absolutely 100% not this. You cannot apply, distribute the power. It does not work, ever. I shouldn't say ever, but it does not work. What we need, no, because it doesn't work. I don't want you to write it down. You can write it down, but just make sure you put it not equal to. It doesn't equal that. This is what it absolutely does equal. Okay? This is the same factor written twice. Remember that? Anything squared is itself 2 times. So I have to multiply this out. Do we remember how to multiply these binomials? This is what's called factored form, by the way. Okay? Let's multiply it out. To multiply it out, I tend to use something called FOIL. Do you know what that stands for? First, outer, inner, last. Okay, so that's what I use. First, outer, inner, and last. Okay? Want to see this written down? FOIL. That's how we multiply the. We're doing FOIL. Okay? So, first is x times x. What is that?
X squared.
Good. X times -1 is negative x, or negative 1x. The inside here is -1 times, to yourself, another negative x. And then our last, there you go. Okay. So we remember how to FOIL. That's a good thing. What do I do to continue? Combine like terms. Good, Will.
Can I do it?
Tell me what it is.
It's going to be x squared plus x.
Minus 2x. We're just combining it.
Oh, just about a minus 2x plus 1.
There you go. April, what was your question, dear?
I never did this FOIL.
What? We did.
Okay, so your teacher might not have called it FOIL. What they might have said is distribute everything. It's the same thing, okay? You're going to take x and multiply it times both pieces. You're going to take -1 and multiply it times both pieces. It's the same thing. You're just distributing everything, okay? Some teachers call it FOIL. Some people call it distributing. It's the same thing.
The best thing to do is just write the first, outer, inner, last.
If your teacher didn't do it before, maybe it'll help you now, but if you like it the way you learned it, that's fine too. I don't care, okay? So that's only step 1. That's all I have done, okay? I've multiplied the binomial in my equation. So I am literally going to replace this with the parentheses in the problem. That's going to be step 2. I'm going to then distribute the negative. So step 2. Replace and distribute. If there is a number in front, which means right up here in my problem, what number was at front? Well, it wasn't really a number, but it was a negative. Would you agree with that? I have to distribute that negative now, but not until after I've multiplied the binomial. So I'm going to replace and distribute. So I'm going to replace the negative. So what do we have? We have y equals negative, and rather than write x minus 1 squared, I'm going to write all of this, what I multiplied to get. X squared minus 2x plus 1. Now, did I have anything at the end that I have to continue to put there? Plus 4. So all I've done is replaced right now. I've just taken what I multiplied out and multiplied by binomial, and now I've plugged it back into the equation. Step 2 tells me I also have to distribute, don't I? So I've replaced, now I'm going to distribute. So what am I going to distribute? The negative. And I distribute to all 3 pieces inside the parentheses. So I have to take this negative, and if there was a number, I'd have to multiply as well, but it's not, just -1. So when I do this, I'm going to have y equals negative, yes it sure would, negative x squared plus 2x minus 1 plus 4. So I've replaced and I've distributed. The last step is just going to be to combine like terms.
So if there was no negative, you would see this.
Yes, exactly. If there was nothing inside outside the parentheses, hang on, let me answer one question at a time. If there was nothing was out front, I would skip step 2. Chris is exactly right. I wouldn't have to worry about it.
You wouldn't have to worry about 4?
I would have to always do step 1, but I wouldn't have to worry about step 2. Okay? All right. Step 3 is to combine my like terms, which in this case are just these 2. We cannot add something that's squared to something that's not. So my final answer in standard form is y equals negative x squared plus 2x plus 3. Very good. This is standard form. I would like you guys to all plug this into your calculator, this standard form. Let's graph it. Let's see what happens with the graph. Okay? So go to your y equals. Again, make sure your plot 1 is not highlighted in your graph. So I believe they might be. We want to make it equals again. We're actually done with the inequalities. So if you want to turn your app off, you can do that, your inequalities app. I'm going to turn my inequalities app off just because we're done with it for now.
But I think I typed it in. Oh, yeah, I typed it.
I'm going to quit it. And then I'm just going to go ahead and plug in my standard form. Negative x squared plus 2x plus 3. I'm going to zoom standard to get a nice pretty graph. And that's what I got. because negative, look right here, negative 1 plus 4. Okay?
Wait, but when we change that y,
Go to the app and go down to the inequalities app and then hit enter and then say quit. So here's my question. Is the graph the same one that we got when we did it in standard form? I'm sorry, in vertex form. Let's go back. Is this graph on the calculator the same graph as this one? It is, isn't it? Do you see that? It is the same thing. So here's the graph on the calculator, and that's what you guys should all have. And it does, in fact, match up with the graph that we created in vertex form. So Raul, it's important that you have this on the calculator because I'm about to show you something important. We found when it was in vertex form that the vertex was a maximum with the vertex at 1, 4. Let's say that it was not given to us in vertex form, but it was given to you in standard form, which is just this guy right here, standard form. Hang on 1 minute. Give me 1 second. It goes away. Where are you? There we go. All right. So in standard form, this is the equation, right? Y equals negative x squared plus 2x plus 3. What if I gave you that equation and told you to find the vertex? Right now, you could use a calculator. Eventually, we'll do it without one. But if you go to the graph, so this is what you want to write down. When it's in standard form, okay? When it's in standard form, you're going to go to second, calculate. So here are the calculator steps. Second, and then you're going to hit the calc button. Everyone find where the calc button is. It's above the trace key. So second, calc. If you're trying to find the vertex, you go to second trace or second calc. So Chris, you should be writing this down, or at least following along on your calculator. And where do you see an option here that would help us find the maximum? Option 4. Okay? Because we already in our mind know according to the graph that it's upside down, so it's a maximum. So I'm going to hit enter. And it's going to ask us some questions. Do you see the little flasher guy that's there that shows up? You have to mark it to the left. Raul, come on, darling. Your eyes were just closed. But you should be typing it in. You don't even have the equation in. So left bound means find where you think the maximum is. Is my little flasher guy right now to the left of the maximum? Go down to maximum. You're going to mark it, so press enter when it's to the left. And I did. Now it says right bound, Travis, right bound. You went to the right? You have, okay, so now you have to move the little flasher guy to the right of where you think the vertex is. So I'm moving it to the other side. And I'm going to press enter because right now, it doesn't matter exactly where to the right, somewhere off to the right, we're going to press enter. And anytime it says guess, just press enter. And it's going to give us a maximum. Now, why do you think, does everyone look exactly like mine, or do you have something that might look a little bit different? Okay, so if you look at, kind of show your calculator to people at your table, okay? You didn't move it to the left, darling. You have to move it to the left, hit enter, to the right, and press enter, guess, press enter, okay? All right, so, shh. Everyone get someone, so you press enter when it says guess. No, you didn't. I just did it for you. Good. What'd you get? Guess, you press enter. When it says guess, you just press enter, folks. Shh. So, the calculator sometimes gives you the exact answer. Okay? Shh, guys. 1.00000000007 is pretty darn close to 1, isn't it? The answer is exactly 1. It's just the calculator uses a program depending on where you marked it. So the maximum is 1.4. Okay? It is, exactly. So I want us to try one more here. Okay? I want us to do the last one that we did, this guy right here. The negative 3, x minus 4 plus 4. No. I want us to take this equation that's already in vertex form. I want you to use your 3 steps. I want you to make it in standard form. And then I want you to use your calculator to find the maximum or the minimum. Okay? So I'm going to pause the recording for a minute. I want you to try your 3 steps first, and then use your calculator to put the maximum or minimum. You should put that totally away, Christopher. A couple people have asked me the same question, so I think it's important to identify with all of us. I don't deal with that -3 until step 2. I don't do that. I just worry about multiplying your binomial. Travis, I don't see your pen in your hand, sweetheart. So that means step 1 is simply going to be x minus 4 times x minus 4. That's all I am doing right now. I'm just multiplying the binomial. I'll deal with this -3 in step 2. All right, so when I multiply these using FOIL, as I was walking around, I saw a couple of mistakes, so make sure you're checking your answers. X times x is x squared. X times -4 is -4x. -4 times x is another -4x. And -4 times -4 is plus 16. When I combine the 2 middle terms, I do get x squared minus 8x plus 16. I have now, all I've done is I have multiplied the binomial. I've done only step 1.
I think I got it.
Good. Let's see if you did. Let's check. Step 2. What is step 2? Replace and distribute. I'm going to be replacing this with this in my equation. And here is where I'll deal with the -3.
Aren't you supposed to combine like terms in step 3?
You do that again in step 3, yes. But you have to simplify this first before you replace and distribute. Okay? All right, so we're going to replace and distribute. So, move this up a little bit. I'm going to have, guys, come on. Y equals -3 parentheses. X squared minus 8x. And then I still have the what at the end? Plus, I don't put the squared. I've already done the squared. Okay, already done the squared. I've replaced. Now I need to distribute. So when I distribute, I'm going to now worry about the -3. Okay? I don't worry about it in the beginning. You can't distribute with that squared there.
Do we put 3 into all of them?
Yep. -3 into all of them. So -3 multiplied by all of these. So I'm going to have -3x squared.
Plus 24x.
Good. I'm sorry, minus what? 52. No. 3 times 16 is 48. And then what you were thinking of is then we had the plus 4, right? I tell you, it's just stretching. Now, step 3.
We gotta subtract 48
There you go. And then we're done. Okay. So we have it now in standard form. Plug it into your calculator. Let's see if we can find the right maximum or minimum. See if it matches what we did before. So we're going to plug it in standard form into our calculator. -3. Shh, guys, everyone keep their mouths to themselves for just a minute. We only have about 5-10 minutes left, and I still have a couple other things I need to talk to you about. -3x squared plus 24x minus 44. And I'm going to graph it. Okay? Does it match the same graph that we had before? Well, let's see. Oops, wrong way. Here's the graph we had before. It is, in fact, upside down, this big old green skinny graph. Does the calculator match it? It does. Okay? How do I find the vertex? Where do I go? What are my steps again? Second calc, and I'm looking, oops, I always want to write on this. Second calc. I'm going to go down to, in this case, is this a maximum or a minimum? It happens to be a maximum again. And I'm going to go, now I don't see my little flasher guy because it's all the way down here at negative 44. I'm going to move it with my arrows until I see it. Is it to the left of where the maximum is right now? So I'm going to push enter. Now I have to move it to the other side, to the right side. And anywhere to the right is fine. And I'm going to press enter. When it says guess, I'm going to press enter. And I'm going to get a maximum 4, 4. Now again, the calculator, 39999 is really 4. So 4, 4 is correct.
We scored. Great, Grandma.
So your homework is just 3 problems. However, you're going to do things other than the directions in the book. You're going to do these 4 things. Change your from vertex to standard form like we did in class by doing your 3 steps, multiplying the binomials, distributing, replace and distribute, and then combining like terms. Find the axis of symmetry, the vertex, whether it's a maximum or minimum, and then graphing it. I'll see you guys next class.